This is the beginning of a video series about Enterprise Configuration Service, or as we call it, ECS. In our platform engineering consulting engagements, we typically start with a solid configuration as a foundation on which to build. We've been building bespoke solutions, and that really limits how many people can make use of the techniques that we strongly believe in. So we decided to build ECS so that today we can make our config management solution available to you. In this series, I'm going to walk you through ECS, and then I'll take you through the architecture and then through some examples that will show you how to move from old-fashioned config, as we call it, replacing it with config served by ECS. And then we'll look at more advanced use cases that will show you where ECS shines in making your config dry, so don't repeat yourself dry. So let's get started with why you need Enterprise Configuration Service in the first place. So for most, configuration pipelines is stuck in the dark ages. What do I mean by this? I mean that if you're embedding config for each pipeline in a parameters or variables file that lives along application or infrastructure code in a repository, you're living with an outdated approach that's been prevalent in the DevOps world for decades. What's the problem with this? The problem is you quickly end up with a lot of config duplication and difficulty in keeping things up to date, such as when new machine images are published, a tag needs to be changed or a new option added to all of your pipelines. How many places do you need to change it in? Where are they? Is it even possible to keep track of it? Also, if somebody wants to see the configuration for a particular team or resource, it could be your billing department wants to make sure that the cost center is correct, for example, how would they? They need access to a broad range of repos just to find out if a cost center tag is correct for a team's resources. So instead they have to raise a ticket and slow down the teams that actually know or might know what the cost center is set to. So if that's where you are today and you want to solve this problem, what do you do? If you're interested in finding out, stick around, as today you're going to learn something. So, as I said, at CTO, we've been building centralized config management solutions for our clients for years. We think we have it down to a fine art. We know structures at work, and in our engagements, we write code to merge these structures in meaningful ways. As we've done it a few times, we usually follow similar patterns. But we know without us designing the config for our clients, they'd do things in a million other ways. So, how would they like it merged? A different way to the way we would. So we write it as custom code, and then the client inherits it and has to maintain it, and enhance it when a new requirement comes in. This means they need to maintain a deep coding skill set, as our mergers are written by professional Python developers, and hence they need to have a high level of skill in order to understand and maintain it, or change it. So for us, that gave us our first requirement. We needed to create a standard config platform that was adaptable to different clients' requirements, so it had to be extensible and configurable. So we decided to give it a simple config language so that you could tell it what to do. There are a few config languages out there already. In fact, Apple just released one called PKL. I don't like their approach as they embed compilation logic into config, and that ends up with code inside your config, and so you need to have a programmer's mindset in order to be able to read it. So it makes it difficult to understand unless all the users learn the language. JSONet's another one, it does the same thing, and config just ends up as a mess. We want to keep ours as clean as possible. Config should be config and only config, and controlling how config is compiled had to be kept separate from the actual config. So we invented this thing called merge strategies that ECS is based on. We had an engagement where a DevOps expert asked us to store secrets in their config. They suggested using Mozilla SOPs. We like SOPs, but we were worried it wouldn't be used properly and secrets would end up being stored in Git. If we rolled it out to a wider audience, they'd just commit something without encrypting it first. Also, users would have to be given access to the encryption keys. That would mean access issues, IAM roles issued out to users, and it would be difficult to maintain. So that became our second requirement, to be able to store secrets without needing end users to have access to keys. As platform engineers, we know the importance of repeatability and self-service. We've been building our self-service solution called Enterprise Self-Service for some time. ECS allows IT operations teams and end users to efficiently deploy Terraform and Helm templates using a service catalog based approach. ECS also needed configs so that we could default options such as AMIs and end user selectable options such as instance type, lists, and allowed DB sizes, fixed cost centers for deployments, etc. etc. I knew that most ESS clients wouldn't have access to a config management system, so I started thinking about how we could turn our knowledge into an easy to consume, low cost product that would address all these needs and more. It had to be multi-user with different user levels such as admin and user, and if the user isn't an admin, they'd need to be granted access to a specific area of the config, as most users shouldn't be able to see everything. If we're going to do this, we wanted to be a configuration platform rather than just a language. There didn't seem to be a configuration platform out there, so we didn't want our users to have to figure out how to integrate that language into their pipelines. So for us, a server CLI combination seemed like the right solution. Had to be able to be deployable in any cloud or on-prem. So Docker image for the server seemed like a logical choice, and a CLI to interact with that server, because a pipeline could do that and a user could do that just the same. It had to be YAML based, as it really is the easiest config markup language. It's very easy to read for everyone, we believe. It had to be compatible with existing pipelines. So to meet this goal, it had to be able to emit YAML and JSON, and maybe other formats in the future. So, CloudFormation consumes YAML or JSON. Terraform can consume YAML or JSON. That was the foundation. We needed to be able to output those different types. So with these requirements in mind, we started building. And 6 months later, Enterprise Configuration Service is ready and generally available for you to take advantage of. We have a free trial, and to give it a try will take you probably about half an hour. I'll pop a link in the video description for documentation and to show you how to get an API key. And this pretty much concludes the first video in this series. The second video is going to be on ECS architecture, and then we'll get into installation and examples in future videos. So I hope to see you in the next video.